Today we're going to see about single-phase induction motor. We already studied about three-phase induction motor. Three-phase induction motor is self-starting motor. It will work by the induction principle. They're having two types of induction motor: screw gauge induction motor, slip ring induction motor. Actually, single-phase induction motor is not self-starting motor. Why it's not self-starting motor? Because it will produce a alternating field. It not produce a rotating magnetic field. So far we want a rotating magnetic field from alternating magnetic field. So far here we are using different type of starting methods. So here we have the theory double revolving field theory. According to the theory, any alternating quantity can be resolved in two rotating components which rotate in opposite direction, and each having a magnitude as half of the maximum magnitude of the alternating quantity. In case of single phase induction motor, the stator windings produce an alternating magnetic field having a maximum magnitude of 5 1m. According to the double field revolving theory, consider two components of the stator flux, each having a magnitude half of the maximum magnitude of stator flux, 5 1m by 2. Both these components are rotating in opposite direction at the synchronous speed ns, which is dependent upon the frequency of the stator poles. So one flux is phi f and other flux is phi b. There is a forward flux, there is a backward flux. Yeah, here we have the pictorial view. So it resultant phi r equal to resultant. The phi f phi b in anti-in-phase is opposite directions, and it phi theta is equal to 90 degree. The phi f and phi b both are in the same direction at 90 degree. As how it's going in opposite direction, both are in 90 degree. So this is the way we have to make a phase angle as a theta is equal to 90 degree. So here we have the diagram waveform. So that it shown the phi f phi b having the phase angle at 90 degree. So actually, if you want to make a rotating magnetic field, these two conditions we have to satisfy. One thing is we need more than one flux, and then the two flux having some phase angle. If these two conditions satisfied, automatically the flux will get rotates at synchronous speed. The synchronous speed depend upon the frequency and power supply, frequency and poles. Torque speed characteristics. The two oppositely directed torques or resultant torque and the result torque can be shown effectively with the help of the torque speed characteristics. It is shown in the figure. It can be seen that at start n is equal to 0. At that point resultant torque is 0. So single phase motor is not self-starting. However, if the rotor is given an initial rotation in any direction, resultant average torque increases in the direction in which rotor is initially rotated, and the motor starts starting in the direction. But in practice, it is not possible to give initial torque to rotor externally. Hence, some modification are done in the consideration of single phase induction motor to make them self-starting. Another theory which can also be used to explain why single phase induction motor is not self-starting in cross field theory. It is also available. Right. So we are having a different type of starting method. Here we have single phase capacitor start motor, capacitor run motor, split phase motor, shader pole motor, small polyphase induction motor. So now we can see how to make a rotating magnetic field from alternating magnetic field. Here this is a trick we are using. Actually, we are using two windings. It's kind of in parallel. One winding we called as a static start winding. Other one is called as a run winding. In starting winding, we have small wire, large number of turns, high resistance. In run winding, we have larger wire, small number of turns, and low resistance. Why we are have the different parameters changes? Actually, we have to make a flux because both are kind of in parallel. Whenever it meet a point, the current is divided. So in each winding, the flux gets produced. This at the same time we want a phase angle between the both flux. So far only need both winding having a different parameter difference. One have the maximum resistance, one have the minimum resistance. Yeah, here we have the view for starting winding. The blue color shown the running winding and the red color shown the starting winding. So it both will combine together. It produces an phi r. It is rotating magnetic field to rotate. Whenever it rotates, it cuts some rotor conductors, so it induces an EMF. The rotor also produces a flux. So both flux are interact each other to experience and force. And then it we are using centrifugal switch also, because why we are using centrifugal switch, we are having a two winding, and the starting winding helps to rotate the motor initially. Once the motor rotates, so using a centrifugal switch we have to open the starting winding from the stator itself. That is a starting winding. So during a normal condition it will take only a running winding. Here we have the capacitor start motor. I already told that we have the capacitance are there. So capacitance produce a leading power factor, so it will make a maximum phase angle between the starting winding and ending winding, as well as it having the centrifugal switch. So once the motor is rotate started, so using centrifugal switch we have to remove the starting winding. Here we have the pictorial view. Capacitor start induction motor, running winding, centrifugal switch, starting winding, and capacitor is available. So already we explained about the operation of the induction motor. Yes. So here we are using two type of motor. One is a capacitor start and run. So here the capacitor is available at starting period as well as at running period. That is the capacitor started and induction motor. Here it is capacitor run in the run motor, the same motor only. இப்பதான் motor. அமைதர். Split phase motor. I have the two windings. One is the starting winding, main winding. Both winding having a different reactance values. So whenever we are providing an input, that current will be divided. So in both winding it produces a magnetic flux. So it have the different phase angle. So it will rotates as a synchronous speed. So it is induced an EMF in rotor. So it produces a current. So there are also one flux is there. So both flux interact experience the force. So here the centrifugal switch is there. When the motor is shorter, so using centrifugal switch we can remove the starting winding. And we have the shader pole motor. Here we are not using two winding. We are using only one winding. But in the corner edge of the pole we are using a shader pole. So when the flux meet the shader pole, it will produce one more flux near to shader pole. So there itself two flux will be formed. The two flux have a different phase angle. So this is called as a shader pole induction motor. So here the trick is, here the arrangement is we done in the stator pole itself. Shader pole motor, laminated core is there, and band of heavy copper, and rotor is there.